Questions 5 through 7 on the 2018 Grade 12 Euclid Math Contest. The perimeter of equilateral triangle PQR is 12. The perimeter of regular hexagon STUVWX is also 12. What is the ratio of the area of the triangle PQR to the area of STUVWX? So here is approximately what an equilateral triangle and a regular hexagon would look like. So they first told us that the perimeter of the equilateral triangle is 12, so that means each of these sides is 4. And since the perimeter of the regular hexagon is also 12, each of these sides is 2. So now we have to figure out the area. Okay, that shouldn't be a problem. Let's first just concentrate on the equilateral triangle. We can easily figure out the height here using the 16/30/90 properties. So that means this is going to be 2 from here to here. So h over 2 is the equivalent of root 3 over 1, since the ratio of the sides of a 30/60/90 triangle are 1, root 3, and 2. So that means h is 2 root 3. So the area of that equilateral triangle, 1/2 base times height, the base is 4, and the height is 2 root 3. So that looks like 4 root 3. Now let's turn our attention to the hexagon, regular hexagon, and we'll chop that into some parts here, like that. And I think that should be sufficient to figure out the area. Okay, so now we have to figure out the dimensions here. And again, this is going to be a right. And the internal angles are 120. Even if you didn't know that, a hexagon is 4 triangles, right? I drew 2. You can draw a line to make it 4. So each of those has 180 degrees. So the total would be 540, or sorry, 720. Now 720 divided by 6 of those internal angles gives you 120. Each of those internal angles is 120. So since this is 90, this angle in here would be 30, and therefore this would be 60. So again, you've got a 60/30/90 triangle. So I'll call this H, I'll call this B, and once again, here we go. So H over 2 would be the equivalent of root 3 over 2. So that means H is root 3. And then B over 2 is the equivalent of 1 over 2. So that means B is 1. So now we can figure out the area of the hexagon. It would first be this rectangle, which is 2 times 2h. H is root 3, so it would be 2 times 2 root 3. And then you'd have 1/2 base times height for this triangle, but there's 2 of them that are identical. So it would be 2 times 1/2 base times height. The base is 1, or sorry, the base, I'm going to treat that as the base. So that's going to be 2h, so 2 root 3. And the height, I will treat that as the height, which is 1. Okay, so this gives me 4 root 3 plus 2 root 3, which is 6 root 3. So now I have to find the ratio of the areas of the triangle PQR over that hexagon. I'll just call it hex for hexagon. So it's 4 root 3 over 6 root 3, and that's 4 over 6. 4 root 3 over 6 root 3. The root 3's cancel, and that's just 2 over 3. Or if you want, you can put it in this format, 2, 3, like that. In the diagram, sector AOB is 1/6 of an entire circle with radius AO equals BO equals 18. The sector is cut into 2 regions with a single straight cut through A and point P on OB. The areas of the 2 regions are equal. Determine the length of OP. Let's make this diagram a little bit bigger, and let's discuss this now. So we are told that that line chops it in half in terms of area. So I'll just call this A in terms of its area, and I'll call this A since they have equal area. All right, and then let's figure out this angle. they've told me that it's 1/6 of an entire circle, and an entire circle is 360 degrees. So if I divide it by 6, it would give me 60. So this angle is 60 degrees. Okay, so what do I do next? I have to figure out the area of that entire sector. So it'll be pi r squared divided by 6. R is 18, so it's going to be 18 squared divided by 6. So that's going to be 54 pi. So that basically means that a plus a is 54 pi. So a is going to be 27 pi. Okay, and I think now we turn our attention to the triangle by drawing a height, where this is, of course, a right angle. Well, again, we can use probably trigonometry. That'd be pretty straightforward, I think. First, let's figure out what is this height. I'll just call it h. So the area of that triangle is 1/2 base, which is OA, times height. And that area is 27 pi. So that means, well, OA is what? 18. They told me that in the question. So that's going to be 18 over 2. H is 27 pi. So H is going to be 27 pi divided by 9, so 3 pi. Okay, so now finally we get to figure out OP, and I can just use trigonometry, sine of 60, opposite over hypotenuse. So that means OP will be H over the sine of 60. OP, H is 3 pi, sine of 60 is what? Root 3 over 2? Okay, so that means OP is 3 pi, invert and multiply, 2 over root 3. So that's going to be 2 root 3 pi for the value of OP. For how many integers k with k between 0 and 18 is 5 sine 10k minus 2 over sine 10k squared greater than or equal to 2? Well, the sine of 10k, just for the sake of simplicity, I'll just call it a, and then, or x, whatever letter you want to use, and then we'll come back to it. So that expression, 5 sine of 10k minus 2 over the sine of 10k all squared greater than or equal to 2 becomes 5x minus 2 over x squared. So let's work with that, and then at the end we can come back and substitute that back in. So cross multiply and you get 5x minus 2 is greater than or equal to 2x squared. Let's put everything on one side, and when we do, we get 2x squared minus 5x plus 2 is less than or equal to 0. So I think this could factor 2x, x, 1 and 2, negative, negative. So if this is less than 0, that means either this is negative and this is positive, or this is positive and this is negative. Okay, well, let's see what happens. For the first one, 2x minus 1 is negative, so that means x is less than a half. X minus 2 is greater than 0, so x is greater than 2. Well, this is a contradiction here, so this one, no good. So most likely it's this scenario, where 2x minus 1 is positive, so that means x is greater than a half, and x minus 2 is negative, so that means x is less than 2. And indeed that works out, x being less than 2 and x being greater than a half. So that is my range for x. Well, x is sine 10. So that means the sine of 10, k I should say, is between 2 and a half, and it's less than or equal to actually So, okay, because this is greater than or equal to sign. Okay, well, anybody can graph this pretty quickly. Just the sine graph, the basic sine graph, you know that one, right? And you know that it only goes between 1 and -1. So this really can be looked at as just between 1/2 and 1, because it can't go up above 1. It can't go up to 2. So we only need to be concerned with that. All right, so we want to figure out for what values of k is this going to be between 1 and 1/2. And in a brief, very kind of sketchy way, we can put 1/2 here. So that means all the values from here to here. So all these guys on the x-axis. So it would be basically these ones. Okay, so how do I figure that out? Well, they told me that k is between 18 and 0. Okay, so that means 10k would be between 180 and 0. So that's my range for 10k. Now I've got to figure out which values are going to give me this range right here between 1/2 and 1. Well, let's just look at 1/2. When is the sine of something 1/2? The sine of something is 1/2. When is that? Well, that happens when theta is 30. And then by symmetry, if this is, say, 30 degrees, then this has got to be 150, because this is 180 right here. So if we went 30 this way, we got to go 30 that way. Okay, so that means my k is my 10k, I should say, starts when 10k is 30, so that means it starts when k is 3, and it ends when 10k is 150, so when k is 15. So all the values from 3 to 15 are going to be solutions. So how many are those? Well, 3, 4, 5, ... all until 15, and I believe that's 13 values, right? 13 values. So that's the answer. In the diagram, a straight flat road joins A to B. Karuna runs from A to B, turns around instantly, and then runs back to A. Karuna runs at 6 meters per second. Starting at the same time as Karuna, Jorge runs from B to A, turns around instantly, and runs back to B. Jorge runs from B to A at 5 meters per second and from A to B at 7.5 meters per second. The distance from A to B is 297, and each runner takes exactly 99 seconds to run their route. Determine the two values of t for which Karuna and Jorge are at the same place on the road after running for t seconds. Let's draw a graph, or not necessarily a graph, but just sort of a line. And there's going to be two scenarios. So the first one is a little bit easier than the second one, so let's obviously do that one first. So Karuna starts here and Jorge starts here. Now, Karuna is running a little bit faster, so she's probably going to end up here when they first meet. And the total distance is 297, right? So let's just say this is x, and therefore this would be 297 minus x. Now, as always, speed is equal to distance over time. Time is equal to distance over speed. So when they meet, their times are equal, the amount of time that they've been running. So when they meet, the time for Karuna is the same as the time for Jorge. And that would be d over s for both of them. So dj and the speed for j. Okay, so dk looks like x. sk, they told me, is 6 in the question. dj is 297 minus x, and the speed is 5 when Jorge is running in that first segment. Okay, so this is the math. This is the algebra. So cross multiply 5x is going to be 6 times 297, 1782 minus 6x. So that means 11x is equal to 1782, and therefore x will be equal to 162. So this is 162, and if you really want to know that one, that would be 135, I believe. Okay, but we are asked to find time. Okay, so we have to find time. So the time, the first time, I guess I can call it T1. You can use either this one or this one. I'll just use this one, seems easier to me. So 162 divided by 6, and that is 27 seconds. So that is the first time they meet. Now we turn our attention to the second time that they meet. Well, the second time is slightly different. They've run all the way to the other end, and then now they are here. Karuna's here and Jorge's here. Now they're running back, so they're going to meet probably here, approximately. So we're going to do pretty much the same thing as before. Not very much different. The only difference is that the distances have changed a little bit. So now dk over sk, same as before, dj over sj. So this is 297, and I'll just call this y, and therefore this will be 297 minus y. So dk, which is Karuna, she goes all the way there, 297, and then goes there. So it would be the 297 plus the 297 minus y. And her speed throughout is 6, so we don't need to worry about her speed changing. Jorge is a little bit different. First he goes all the way there, so 297, but when he's going in that direction, he's traveling at 5 meters per second. But then he turns around and comes back that way. So it's y, but this time his speed is a little bit different, 7.5 according to the question. Okay, so now we have really just one variable, so we can solve. Okay, so this becomes 594 minus y over 6. Get a common denominator, and when you do, top and bottom here by 5, top and bottom here by 7.5, like that. And when you do that, you get 227.5 plus 5y, and the denominator is going to be 37.5. Okay, cross multiply, and when I do cross multiply, I get 22275 minus 37.5y, and then on this side we will get 13365 plus 30y. So that means 67.5y is going to be equal to 8910. Divide through, and we get y is equal to 162. But notice this is a distance. We have to figure out the time, and I call it T2. And as before, you can sub it into either one of these. So let's do that. So I'll just use this one. Seems a bit easier. So 594 minus 162 divided by 6. And that looks like T2 is going to be 77 seconds. So the first time they meet, it's after 27 seconds. Second time they meet is after 77 seconds. Eight people, including triplets, Barry, Carrie, and Mary, are going for a trip in 4 canoes. Each canoe seats 2 people. The 8 people are to be randomly assigned to the 4 canoes in pairs. What is the probability that no 2 of Barry, Carrie, or Mary will be in the same canoe? All right. Well, first thing, like any probability question, we've got to figure out the total. And that's going to go in the denominator, and then we will concentrate on the numerator, which is our specific condition. Well, we've got 8 people. So the total, I'll do it over here. From the 8 people, initially choose 2 for canoe number 1. Then from the remaining 6 people, choose 2 for canoe number 2. From the remaining 4 people, choose 2 for canoe number 3. And from the remaining 2 people, choose 2 people for canoe number 4. That is the total possible arrangements. So when you do this math, you have to multiply these, by the way. It becomes 28 times 15 times 6, and that is 2520. So 2520 is what goes in the denominator. Now, we have to figure out the numerator. And the numerators are a specific condition which states that no 2 of Barry, Carrie, and Mary will be in the same canoe. All right. I think it's a little bit easier to figure out the opposite, where they are in the same canoe, and then subtract it from 2520. So this number is where they are in the same canoe. Okay, so let's talk about them. There's Barry, Carrie, and Mary. So the possible combinations where they are together would be BC, BM, and CM. All right. So canoe number 1. If canoe number 1 has BC, let's say, let's talk about the first one. Then canoe number 2, canoe number 3, canoe number 4. Those are going to be a wide range of combinations involving the other 6 people. Well, this is fixed, so there's nothing we can do there. There's one possible way of doing that, BC in canoe 1. Now, for canoe 2, from the 6 people that are remaining, choose 2. For canoe 3, from the 4 people that are remaining, choose 2. And for C4, from the 2 people that are remaining, choose 2. So that's going to give me 1 times 15 times 6 times 1, which is 90. Okay, that's a very important number, 90. Now, BC can also be in canoe 2. It could also be in canoe 3, or it could be in canoe 4. And for each of those, in the exact same way, you would get 90 different combinations. But we now also take into consideration BM and CM. BM and CM would be the same story. So BM would also give you 4 of those 90s, just like how I got 4 90s here, 4 times 90. And CM would also give you 4 times 90. So you add this, this, and this. So that looks like 3 times 4 times 90 to get the total, where they're together in one canoe, 2 of the 3. So that's 12 times 90, and 12 times 90 is 1080. So that's what you put here, 1080. Okay, so let's do this math. So that's 1440 over 2520. And in lowest terms, that will be 4 over 7. Diagonal WY of squared WXYZ has slope of 2. Determine the sum of the slopes of WX and XY. Well, the first thing we need to draw is some sort of a diagram to understand this question. So let's first draw an approximate line that has a slope of 2. And that would be a line like this. So I purposely drew it so that rise over run is 2, right? The rise is 2 and the run is 1. So this is, as you can see, 2 and 1. Okay, so now we have to draw a square. So a little bit tricky. It won't be perfect here, but let me attempt to draw a square that has that as the diagonal. So here you go. Approximately, that's a square, right? Sort of. Okay, so now we have to talk about this question. Let's label it first, WXYZ, WXYZ. And then they want us to figure out the slope of WX and the slope of XY, and then we have to add them because it's a sum. Okay, so let's see here. We know a few things. We can go back to that 2-to-1 ratio right there. Remember that 2-to-1 ratio where that green line is representing the slope. So I can actually use that to figure out an angle, and that angle is right here, this angle. Tan of theta will be 1 over 2. Opposite over adjacent. That's 2, since that's 2. So we are allowed to use calculators on the Canadian exam, so figure out theta. And when you do, you get 26.656 approximately. Okay, so now this is a square, so that basically means that when you were to cut the diagonal, this angle will be 45 degrees. And therefore this angle we can easily figure out, since that's going to be 90 minus theta minus 45. So that angle will be 90 minus 45 minus 26.656, and that is 18.4349 approximately. So this angle right in here, 18.4349. Okay, so now I can concentrate on WX. WX, let me draw that line in there, make that a perpendicular. And therefore, the tan, again, of that 18.4349 is going to be pretty much the slope of the line WX, because it's rise over run, correct? Opposite, which is the rise, over adjacent, which is the run. So that is the slope of WX. So get out your calculator and type in that. And when you do, you get exactly 1/3. Interesting. So that's the slope of WX. Now, how about the slope of XY? Well, XY is perpendicular to WX. So because it's perpendicular, its slope will be the negative reciprocal. I think you guys remember that. Negative reciprocal for lines that are perpendicular. So what's the negative reciprocal of 1/3? Well, first take the reciprocal, 3 over 1, and then hit it with a negative. So the slopes of WX and XY are, WX we had 1/3, XY is -3. And then we have to add them because they want the sum. So it looks like that would be 1 over 3 minus 3 over 1. Get a common denominator, 3, and that's going to be 1 minus 9, so -8 over 3.